Assalamualaikum. Last class we had done on Gauss elimination. Okay, we had done this exercise. Okay, for linear algebraic, we have matrix and iteration. We have gone through Gauss elimination. Okay, so later on, we will do one more exercise on Gauss elimination. Then I will proceed with LU decomposition, which involve matrix as well. Okay, after we finish LU, then only we will go for the iteration method. Okay, for last class, any question on how to solve the matrix? Clear? So today we try to do one more exercise for this regarding Gauss elimination. Then later we discuss and proceed to LU. Okay, given the following equations, 3 equations. So it asks you to compute the value of x, y, z based on the Gauss elimination method. Okay, usually in final exam, you will be given this kind of algebraic method, then you will need to solve it either using matrix or iteration, or both. Okay. Okay, first step, convert it into matrix form. Okay, then make it into augmented matrix, or you can just straight away do in augmented matrix. Okay, in Gauss, you need to zero the bottom triangle, zero this part. Find the factor that can zero those triangle. Okay, try to proceed. Later, let's share the answer.
Volunteers to share the answer. Okay.
Judah, can you snap the question first? I want to unshare the screen. Got it? Okay, so can someone share the answer on the board? I want to see answer. Either you write it on the board or share it in my send to my screen. No one will check. Okay, up to you. So what's your answer for your X and Y and Z? Wait. X is 1.21, Y 0.75, negative. Z positive. The rest get the same? Okay, how to know your answer is correct? It's either you use the calculator, the one that we did last time, or you input back the value that you get into one of the equation over here. Let's say x, y, z, this value you input into equation, the first equation. So can you get the same value over here? Yes.
Y is 0.75 is
Negative?
0.758.
3 decimal point.
Yeah, and so D is 0.595.
Okay. Okay, so it's in the range. Both answer I will accept. It's in the range. As long as it is in the range. Unless, let's say, y you say you get negative 1.75. Then that is totally wrong. Okay. Okay, you must show the step by step how you get the value. the pivoting, the factor that you find, because each factor get half marks. Okay, and then the final answer will get 1 marks for each. Any question for Gauss elimination? Yeah. Now the rest of the slides which discuss on the pitfall of Gauss elimination, the limitation. This one I want you to read on your own and try to understand. If you cannot understand, let me know. Okay? Because there are few limitations when you cannot use Gauss elimination. Okay? Now this one I will leave it to you. I want to proceed to LU. LU decomposition. So for linear algebraic, as I mentioned earlier, okay, for linear algebraic, we will have 3 methods. Gauss elimination and LU is matrix method, where they are related in a way. You will get same final answer. It's just that LU is more, how to say, complicated, a bit complicated. Okay, not to say complicated, it's just that expanding from the Gauss elimination. Now, for the iteration method, you will have later on Jacobi and Gauss-Seidel. Okay, don't mix up. Gauss-Seidel is iteration method. Gauss elimination is matrix. Okay. Now, for the LU decomposition matrix, once you, after you convert your linear algebraic into matrix form, then later you will need to form them into lower and upper matrix. LU here stands for lower and upper matrix. Okay, so for the upper matrix, similar to Gauss elimination method, you must zero this part. The bottom triangle, zeros this part. Okay, same as Gauss. Then for the L, the lower bound matrix, this is the standard format. Okay, then this X is the value that you get from the U. Meaning that this one, you want to zero it, you need to find the factor, right? Okay, so this factor, let's say for this factor is to zero this R prime 2, 1, for example. Okay, so this factor is the one that you will input over here. Okay, so similar to factor to zero this value and this value. So the factor to zero this value will be substituted into this part. So that is your lower bound matrix. Okay, so that's the difference with Gauss elimination. Gauss, you just find the upper bounds, then you proceed. Forward elimination, then back substitution. For LU, forward elimination plus this lower bound matrix. Okay, it includes this lower bound matrix. And then it has its own equation. Okay, now let's try for the LU decomposition. Given this example, okay, given this equation, the question asks you to find the LU, find the x1, x2, x3 using LU method. Okay, first step, as always, in Gauss elimination, convert it into matrix form. Okay, so you should know the label of your matrix, because later on this one will be used in the equation over here. Wait, let me make it clearer. Okay, this is the concept of LU. Okay, concept of LU. AX equals to B, which is the original matrix. A multiplied by X equals to B. That is your original. Now, UX equals to B. Later on, from A, you will decompose it into L and U matrix. Okay, so UX equals to B. UX equals to B. Wait. Something wrong here. Wait, let me check. Here, sorry. AX equals to B means this A is LUX equals to B, right? This is from the A. Okay. Now, UX equals to K. LK equals to B. Okay, the decompose. This one you must memorize. Later we will need to use this. Okay. Now, I show you the step by step. From this metric, we decompose it into L and U. Yeah. U is the one that you need to eliminate the bottom triangle. Okay, we pivot the first row. Then we need to zero this part. Okay. To find the new matrix, you need to find the factor. Okay, so we need the factor. To zero R21. So R2, this one is the original. Okay, R2 minus 64 over 25. R1. So this is your factor to zero this row. Okay, so from here you get 0. Okay, that is clear. Same as Gauss. Now, same thing for the rest of the value. So here you will get negative 4.8, negative 1.56. Okay, 0, 16.8, negative 4.76. Okay, this is the first part. We need to zero this part. Okay. The third row, the factor would be R31 minus 144 over 25. Okay, so this is the factor to zero the R prime 31. Okay. Now I move to here. The final U matrix. Okay, this part we had zeroed, we must zero it, then this one you will get 0.7. Okay, this, the R, I write here, the R prime 3, 1 is this. Okay, so this is the factor to zero this part. So this is your final U matrix. Okay, final U matrix. Now, from the factors that you find out over here, this value will be substitutes in the L matrix. Okay, just follow me first. So your L matrix, it will form, this is standard. Here will be your factor from the first factor, which is 64 over 25 just now. The first factor. Then here will be the second factor, which to zero this value. Okay, and then this one is the third factor. Okay, so that is your L matrix. I copy back the U matrix over here just now. Okay, okay, we got your L and U matrix. So far, any question? Yeah. Then the next step is using the concept just now. From the equation earlier, this one, we must find the K first. K, it is in equation 1 and equation 2. Okay, from the matrix, equation 2, L is known, B is known. So using equation 2. Now using equation 2, okay, this is L. Then your unknown, K1, K2, and K3 equals to the B. Okay, then from here, we should find the K value first. From the top one, you can get your K1. Okay, which is this value. Okay, then subs K1 into equation 2, you will get your K2. Your K2 here. Wait, I show you step by step. Okay, second row. K1 is known, so subs into here. Then from here, you will get your K2, which is these values. Okay, so same thing for K3. Okay, then subs the known value K1, K2, you will get your K3. 0.76. That is not the final answer yet. Okay, so this is your K. Then with the known of K, input into equation 1. Okay, then using equation 1, which is the Ux equals to K. U is known, the one that we find out earlier. K, the one that we get just now. Okay, so subs all into the matrix back using matrix U. Okay, this is your matrix U. Then your X. Okay, this one equals to your K, the K that you calculated earlier. Okay, so from here, X3, using the last row, you can get your X3. Okay, subs X3 into the next equation. Here you will get your X2. Okay, same thing for X1. Subs all the knowns value. Your X1 will be 0.22. Okay, so that is your final answer for the matrix. This is LU method. The additional of the L matrix. Okay. Again, I go from the beginning. I repeat again. Okay, I repeat. This is the given question. First step is to convert it into matrix, then decompose it into L and U. Okay, decompose into L and U. LU matrix. So U matrix, find it using Gauss elimination method. Matrix U, where you need to zero this part. Okay, the factor to zero that part will be used for L matrix. Okay, so this value will be input into the L matrix. This one. Okay, so from there, using equation earlier, this equation, this concept of LU. Okay, this concept of LU. LK equals to B. This is the one that we need to use first because L is known, B is known. If you want to use directly equation 1, which is Ux equals to K, X is the one that you need to know, the one that you need to calculate, unknown. K also here is unknown. You only have U matrix. So that's why we proceed with equation 2 first. L known, B is known. Then get the K. Okay, this is the K value. Once you get the K value, then plug in into the first equation, which is Ux equals to K. U, the one, the upper matrix, K, the one that calculated just now. Now your unknown is only the X. Okay, so from here, you get your X value. Okay. So, yes. Sorry? Huh? This one. Okay. So the difference with the Gauss elimination is LU, it has L matrix. L matrix. So from there, find the unknowns. Okay. Now let's try one question. Now let's try this question. Now example in class, I give straight away the equation. Usually in assessment, you will need to find out the equations. Perhaps you will be given a process. So from there, you need to come up with the equation. Okay, let's try. Let's try. You try first, then you see which part will start. Yes. This is negative 11. So here is negative. I miss out the negative. Okay, so we are running out of time. Please make sure you get the correct answer and make sure you know the step by step LU and then the concept of LU. Okay, this thing. Next class, we will do one more question for the LU. Then I'll proceed to the iterative method. Okay? Okay, that's all for today. Thank you. For those who haven't scanned, can scan.